All right, so what is oh, and I was saying earlier before, we had our technical difficulties that there's a little bit of a lag in these videos, and from the time that I say something in real time to the time that you say is like a couple seconds, 5 seconds, 6 seconds. But the main way we can interact it's I can't hear what you're saying, and earlier, ironically, you couldn't hear what I was saying either. You can't hear you can hear me, okay, hopefully. I can't hear you, but the main mechanism for interaction is the comment stream. So if you have a question, post it in the comments, and then I'll be able to see it. Another thing is these streams are public, so hopefully we don't get like bad actors who join in here. But I'm not going to limit the stream to just the class unless it becomes a problem. In which case I'll have to send you a link so that you can join the stream, but other people can't. All right. But for the time being, I won't do that. All right. So let me ask you a question. All right. Let's say there's a car, and this car is going down the road, and at one moment in time it's right here, and sometime in the future it's over here. Okay, so it's moved from one point to another. I'm going to call this initial point x0. All right, that's another name for that is x naught, or the initial position. And you had a stopwatch, so you could time how long it took, t, to go from point x0 to point x in the future. And what does that tell you about reality? What does that tell you about the nature of the car? You know where it was, where it is, and how long it took to go from one point to another. What does that tell you? What does that information allow you to do? Well, one thing you could do is you could say, well, I have some idea. This information would allow me to have some idea about how fast it's going. And well, how does that work? Well, everybody who's lived in this world for a reasonable amount of time knows that we can quantify how fast something is moving in space using what's commonly called a speed. In physics, we'll use a more specialized term called velocity. But the basic idea is these things, these quantifications of speed or velocity, have units of distance in a given amount of time. Your car, miles per hour, meters per second, kilometers per day. It's always, you can think of many different permutations of the units that you would use for something like this, but it's always a measure of distance divided by an amount of time. So if you had information about the distance a car traveled, and in this case you could figure that out. It would be, well, where is it minus where was it? X minus x naught. And you have information about how long it took to travel that distance, then we can estimate how fast it's going. Speed equals distance over time. Okay. And in other words, that quantity divided by that quantity. And maybe we say that that's a new symbol V or S for speed, but we're going to use V because physicists like to use a different term called velocity. Okay. So I have this formula, move this up here, V equals a change in position, x minus x naught, over time. I have this formula, and this formula it's mathematics. It's mathematics. Is that the real thing? I wish you could talk right now so I could hear you. Is it, throw some comments up if you have any. But is this mathematics the real thing? I mean, no, it's not. It's not the real thing. So what exactly are we doing here? What we're doing is we're modeling. We've created a model for something that's in the physical world, and the form that model takes is a mathematical equation, a mathematical formula. And you think about in art. You guys ever see the Starry Night? Of course you have. Van Gogh's Starry Night. What is that? It's a model. It's a model of something that was partially in the real world, whatever that is, that Van Gogh saw, and it's partially something that emanated from Van Gogh's brain. But it becomes a model of something else. And in that case, the model takes the form of paint and brushstrokes and texture and colors. All right? In physics, the model takes the form of mathematical equations. Okay? And in this semester, I'm going to teach you at least two different ways to think about mathematical modeling. One is, let's call it the algebraic approach, where we have formulas and you manipulate them algebraically, and the solution to a problem comes from understanding what you know and what you don't know and trying to map those two things together. Okay. Another approach is to I only have 2 minutes here to do, because I screwed up the audio. Another approach is to do something that's called computational physics, which involves numerical approximations to physical problems. Okay, and the two are related, but we're going to look at these two different approaches. The second one, computational approach, in lab exclusively. So let's go back to this model here quickly. And if we think about this a little more critically, what we understand is that this formula is actually an estimate of how fast that vehicle, that car, is traveling over that interval of time. But what we actually know is that this is an average. All right. So this model, sorry, that came out poorly. It says average. That model is a model of, on average, how fast is that object traveling over that interval of time. And so what is the meaning of that? Well, let me give you two examples of very different behavior that might yield the same average. One would be the car speeding up, and the other, the car slowing down. But if you have those two scenarios and the distance traveled is the same and the interval of time is the same, that formula is going to give you the exact same number. All right, it's a model of what's happening during that time. But I got 10 seconds. What is the use of a model? In physics, the utility of a model is, does it make predictions? Does it make predictions about what's going to happen in the future? And or does it make predictions, if you know what's going on right now, can you understand what happened in the past? And that is really the focus of the discipline of physics, using mathematical models that make predictions about the real, whatever that is, physical world. All right. So I got to stop for now because my time's up. But I will see most of you tomorrow afternoon during the lab session and the rest of you I'll see on Wednesday, and we'll continue this.